Welcome, everyone, to another episode of Heat Treat Radio. I'm your host, Doug Glenn. I'm also the publisher of Heat Treat Today. And you can find out more about Heat Treat Today at www.heattreattoday.com. Please feel free to do that after you listen to this wonderful episode. Today, we're going to take an interesting journey into the mind of a captive heat treater and discover how she thinks about heat treating when it comes to integrating new equipment and processes into a manufacturing process, basically. This will undoubtedly be a very interesting episode. As most of you regular listeners to Heat Treat Radio know, most of our listeners are in fact captive heat treaters who have their own in-house thermal processing. Being able to pick the brain of one of those should be very interesting. So let me introduce you to Caitlin Kirsch, who is going to be our victim today. We're going to get to talk to Caitlin. And Caitlin, I'm not going to do too much in the way of an introduction, except to mention the three companies that I'm aware that you've worked at. And then I want you to I'll ask you a few questions about your background in way of introduction. So from what I understand, first off, let me say this, that you have a degree in metallurgical engineering from South Dakota School of Mines and Technologies and a master's from Strayer, I believe, in project management. So that's good. I do want to mention that. And then Huron Casting Corporate Services, or Huron Casting, it was one of the companies that you worked at. And then also Federal Screw, and then most recently at Moeller Aerospace, right? Those are the places. So first off, I want to welcome you. And then can you tell the listeners and viewers a little bit more about your just very briefly what you did at each of those companies?
Yeah, so at Huron Castings, first job out of college, I was a metallurgist there. So while I was there, focused on just overall quality of our product. So from the point of alloying into a furnace where we cast it through our heat treat processes there, making sure chemistry is good, hardnesses, everything. Federal Screw Works, I was the Met Lab supervisor. So I ran our metallurgical lab, managed our thermal processing on our neutral hardening, quench, temper furnace, our subcritical anneal, and all of our induction processes in house, and then manage the quality from all of our sub tier heat treaters that we had to use while I was there. And at Moeller, I'm currently in the quality engineer role there, but I'm helping them bring in their metallurgical lab and then coming up bringing in heat treat and potentially braze.
Okay, yeah, very interesting. A good sampling of all things going on, across the board there. I think that's really interesting. The last thing I do want to mention to the listeners and viewers of this podcast is that Caitlin is one of the 40 recipients of our 40 under 40 award for 2024, which was very nice. So congratulations on that. That's also very nice. One of the rising young leaders in the industry, which is very good. Okay, so I would like to ask you a little bit more about your time at Federal Screw, because I understand when you were there, you were involved. And I'll tell you why I'm asking the question is I want a lot of our listeners to kind of get inside of your head on how does it work inside a manufacturing plant that's doing thermal processing? How do people think about integrating new processes, new products, and things of that sort? You were responsible for introducing a new part line there at Federal Screw?
Yeah, so while I was there, we already had our neutral hardening and temper line. We had one induction hardening process. When I started, we were getting ready to bring in another induction hardening process on half shaft axle bars. So we got the equipment probably about a year and a half after I started there. And I was responsible for getting the line running, getting conforming parts off our heat treat line. And I did induction before, and so I figured this isn't going to be too difficult, and I was sorely mistaken. Uh, it was a lot bigger project than any of us anticipated. We were bringing parts in from the incumbent, which was our customer as well.
Okay.
And they've been doing the parts for 40 years, so they knew exactly how to do this. They've been doing it, and we're coming in and right off the bat trying to get going. And with COVID and everything at the time, it really
Okay.
shrunk our developing process. So we were on an expedite trying to get it going. So it was just throw it at the machine. We're going to
Yeah.
try X, Y, and Z and just see where it ends up and just start tweaking and try and get to know the equipment while we're developing. And it was a long, grueling process.
Yeah.
It was a
Yeah.
it was a lot of long nights.
I can imagine. So, were you involved in the selection of the induction equipment, or was that already done when you got there?
They had selected the equipment before I was there.
Okay.
But past that, I was involved with the selection of the lab equipment and doing the runoffs and working with the equipment manufacturer, make sure we had everything we need to have.
Yeah. Yeah. And that whole process was, like you said, it was painful, primarily, I suppose, because uh, of how quickly you had to have it up and running. You just didn't have time to really thoroughly vet it. Would that be accurate?
Yeah, it was a very expedited process. So it was,
Yeah.
after we had the equipment set up, we kept on hitting one hurdle where, okay, this isn't working. Now I have to pass this hurdle and
Yeah.
try and get past. We come up to a speed bump, fix it, and keep on moving forward.
Yeah. On the team there at Federal Screw, how many people were involved, would you say, integrally involved, importantly involved in the integration of this new induction process? How many people?
So on the actual heat treat process itself, it was primarily myself, and then our engineering manager was setting up the rest of the line. So
Okay.
our engineering manager, our manufacturing manager were trying to set up the machining process because we were trying to do everything in one, like a robotic line. They load
Okay.
parts in the machine and it just continues through until they leaves the temper furnace. Uh,
Okay. So you were trying to automate the whole thing.
yeah.
Okay.
But those two are trying to handle the manufacturing side, and we had a program manager who was trying to help on the heat treat side, trying to help at least arrange people. So we had people to help with testing, help on any of the mechanical side if I needed help trying to work on a machine. And we had a
Yeah.
couple programmers in charge of the automation of the robots.
Yeah.
On the heat, but on the specific heat treat side, it was primarily myself and then my lab techs trying to run product, test product, run
Yeah.
more samples, test more samples.
Trying to get it right. Yeah.
Yeah.
Besides the internal team that you worked with, did you find yourself utilizing any external resources external to Federal Screw? Did you have to go ask people here, besides perhaps the company that you were doing the work for?
Besides the company we were doing the work for, we didn't really go outsource until we tried eliminating heat treating a certain area of the part. We were getting quench crack failures on these parts that
Okay.
it was almost just inherent to the process of how the part had to be heat treated, and there was certain things you could do to mitigate it. You could try to eliminate for a little bit, but it was something that was inevitably going to happen. It was a
Yeah.
very thin section. Heat that up to hardening, quench it. I'm pretty sure that what's going to happen.
Yeah. As we say, it's not all cracked up. It's supposed to be.
Yeah.
It cracks a lot. And I don't want you to say, because we want to be respectful of Federal Screw as well. We don't want to say more than what you. But did you say? Are you able to say what the part was? I think you mentioned maybe at the beginning what it was.
Half shaft axle bars.
Half shaft axle bar. Okay.
Yeah.
Okay. Gotcha. Okay. And now, so before we move off of Federal Screw into really, I want to talk to you a little bit more about Moeller. As you look back on that experience, were there any major lessons that you brought with you to Moeller? Any major things that you learned about the metallurgical industry, or your specific job, or Met Labs, or any of that stuff?
Yeah. So I think overall is, going through school, you're going to learn all of your technical, just all of your technical knowledge, all of the theories that you're going to apply throughout heat treating.
Right.
But working, especially at Federal Screw Works, it was one of those things that you learn the most from the operators. So, you know, becoming a good friend with my operators at Federal Screw Works, I learned a lot more about the heat treat process of, what I would need to tweak in a furnace. I know what a book's going to tell me to do, but
Yeah.
a book and practice are not always the same thing.
Yeah. Yeah. No, so when you say operators, you're talking about like the induction equipment operators?
Yeah, induction equipment operators, uh, or like a hardening furnace operator, temper furnace operator. On the induction machine, I was so integrated in that process where, I could get my data from a test bar and know, okay, like I need to, up my amperage this much. I need to take it down this much. So that process, I was so involved with that. I knew more than our operators there because it was just a robot running it essentially. So if I was gone, it was just a call to either the manager of the line to, hey, go up it, go up, just go take out 5%, test it. It should be right where you want it to be.
Yeah. 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 Very interesting. Uh, I think that's good. Maybe one last question is about Federal Screw. Were you able to, I don't know how sophisticated they are there with their equipment. Were you able to monitor that stuff remotely?
I was actually. So the equipment that they purchased for that line, I was able to log in remotely through TeamViewer onto the computer system and either help them recover from a failure if I was offsite or if I was home. If the machine crashed, if they were getting bad errors, I could be able to log in, see what was going on with the machine, give them direction, what to do. A lot of the time it was a phone call and telling them, hey, watch the robot, make sure I don't crash into anything and break it, and just start
Yeah.
moving everything from home.
Yeah. Now you say robot. Was it actually a robot or was it more just like a scanning station or what? What can you, how
Oh,
comfortable are you describing that?
it was a gantry system, so the parts would leave a cleaning line and would basically just roll over to the machine. A gantry would pick them up,
Okay.
bring them, put them in the machine. Then the machine itself was a scanning induction machine, so it would
Okay.
do the hardening.
Yeah.
Then the gantry would take those parts out, put new ones in, and
Gotcha. Yeah. Because you were talking about half shafts. I assume you had a scanner, an induction scanner of some sort
yeah,
that would be treating that. So it was basically a gantry system to load and unload.
yeah,
Yeah. And then after when it unloaded, it went straight from there to a temper furnace.
yeah. So I went back to another conveyor, and the conveyor rolled straight over to another robot. Essentially, I would pick them up, put onto another conveyor that would take them over to the temper furnace.
Yeah. And probably did the robots load a basket full for the temper furnace? I'm assuming.
So it was a continuous temper, so it
Oh,
had
okay.
slots
Okay.
essentially that the bars would rest in.
Gotcha. Gotcha. Vertical, perhaps vertical processing
Yeah.
or whatever. Okay. All right. Super. And how? Well, let's move over to Moeller. First off, what motivated the move to Moeller?
Mainly life changes. It was, we were looking for our next place to go, and Federal Screw Works Big Rapids wasn't always going to be our lifelong place.
Yeah.
So, it was had options open. It was, and I'm going to dog on Ohio a little bit. It was like move to Ohio or move to Northern Michigan. And I'm an outdoors person, so Northern Michigan would fit my lifestyle better.
Yeah. Okay. Gotcha. Federal Screw was where? Where were you? Grand Rapids, you say?
It was Big Rapids, so it's like a
Big Rapids.
45-minute drive from Grand Rapids.
Okay. Okay. And Moeller is in Romulus. Where's that's the
Moeller
corporate head?
is in Harbor Springs.
Okay.
So
Okay.
I'm gonna do my
Yes. Right.
Michigan thing here. It's like
There
at
you
the
go.
tip of the mid up here.
Yeah. All the way up there near Mackinac. Isn't Mackinac up there somewhere?
Yeah, I'm about half hour from Mackinac, I think.
All right. So, I have to ask, being of this certain age, have you seen the Somewhere in Time movie?
I have, yes.
Okay, very good. Well, you're all right then. So you got all the important stuff in Northern Michigan covered if you've seen that movie. So there you go. Okay, so life changes. Wanted to get up there, which is fine. We won't pry anymore into the life changes part. Yeah, that's all good. But tell us about what have you been tasked with at Moeller?
Yeah, so at Moeller, I am for it's an aerospace, so I'm a vein nozzle QE, but coming up to molar, I think it was probably the main reason they offered me the job was to help bring in the metallurgical lab first. So our quality director came from another company that they had everything in house between their metallurgical lab, coating, heat treat, braze, so they didn't have to outsource a lot. Coming in, it was like, okay, let's start building our plan for a met lab. And we're a couple months away from doing our first audit, so I'm excited.
What are you being audited for if you're able?
Yeah, so with aerospace, you have customer specific audits and then you have NADCAP audits. So
Yes. Okay.
with with our primary customer, who's probably about 80% of our business, we are going to be doing their audit first so we could start auditing their product in house and then we'd be going to NADCAP approval after that.
Yeah. Okay. Yep. That's good. That's good. All right. And so you're involved now with the NADCAP audit. Will it be NADCAP for heat treat or NADCAP for met lab for a metallurgical lab for testing?
It'll be the Met Lab first.
Okay. So have you already purchased most of the equipment for the metallurgical lab?
Yeah, so that was my first task. So we're focusing mainly on metal graphic mounts first. We're not going to be getting into the hardness testing and such yet, but we purchased all that. We had that delivered probably about midway of last year. So it was finally finished being hooked up and water plumbed, all of our venting done in November of this past year. So we've been able to get in, actually start working with the equipment, getting prepped for an audit, making sure everything's in alignment. We're not missing any piece of equipment.
You do your own heat treating there though of this part?
We will be. So we don't have heat treat yet in house.
Okay. Okay. So tell me a little bit because I'm curious. This is really what I think one of the most interesting things that I'd like to know, and I'm sure some of our listeners and viewers would like to know the process for, for purchasing the lab equipment. How many people were involved? What rehearse with us. What did that take? Was that a painful process? Was it easy? Was it
It was actually pretty easy on my part coming from the automotive sector where I was very high volume lab. I knew the nuances of equipment, nuances of training people in a lab. And, in my opinion, one of the hardest things to train is teaching somebody how to grind and polish a mount. It's, it's hard to do. It's very finesse. Even people who've been doing it for 20, 30 years can mess it up if they're doing it by hand. But I essentially was given a budget after I initially picked out equipment and I was told keep it under X amount. And so I picked the equipment, set it off to my boss, and he went to the CEO and had the sign off for the capital purchase and got everything ordered.
okay? All right. And did you go with primarily? I don't want to know company names or anything of that sort. But did you shop it around much, or did you just basically go with the equipment you were comfortable with from the past?
A little bit of both. There was two manufacturers that's the equipment I've worked a lot with in the past that I liked, and I essentially decided to go with a manufacturer that was more stateside, so I could get real time help if I needed it, but also price range. So their price range left it to where I could get a lot more of the equipment that I would need for it and try to keep it under budget.
So being somewhat stateside was important here for service and replacement parts or whatever if you
Yeah,
need it. Yeah. Okay. Good. And so the only other people involved with it sounds with your boss and just the CEO to sign off
yeah.
on the thing. Just curiously, how large is Moeller employee wise? Do you have any idea?
Um, I think we're about 270, 300
Okay.
employees.
Okay. That just gives a ballpark. So under 500, under
Yeah.
500. So okay. Yeah, that's really good. Uh, so so you've got the testing equipment purchased. You've got it in place. You've got it basically to the point now where you can start getting the certification that your customer requires. Right? You'll
Yep.
get that. You'll get that down. and then move on to a general NADCAP certification.
Yeah.
Yeah. Okay. Yeah. Very good. Any and is this your? Have you done the audits before? Have you had audits before?
So, not lab specifically. So, in automotive, I had to do the CQI-9 self-assessment, and then I
Yes.
was always involved with the audits when we had our IATF audit at Federal, and
Okay.
had to walk them through the heat treat, walk them through the lab side of that
Yeah.
audit.
Yeah. But this is the first. This is the first lab audit per se.
Lab the first lab specific, I reviewed their specs, so I'm just like, "Well, shouldn't be too bad."
Okay. Well, and are you in the midst of it now, or are you have? Where are you in the process?
We're prepping for it currently, so we're aiming for a March audit date
Okay.
from them, so we're just in the
Oh,
final stages of documentation and
yeah.
things
Yeah.
like that.
That's coming right up. Any anything else jump to your mind regarding the audit process or equipment selection process that you think would be helpful to other people that may be in your shoes? Any lessons learned?
I would say, if it's something that you're not familiar with, if you have a colleague that has equipment that you can get your hands on, or, if you're in the position that we're in, like we're trying to bring stuff in-house and you have a good relationship with your customer who might have a lab or something, see if, you can get in and work with that equipment, see the equipment. I know there's a lot of companies that have like satellite labs that you can go in and see the equipment firsthand, but that's what drove a lot of my purchasing on the lab equipment itself, was knowing on a familiar side of what works well, what we would need to make it easy training process, make it as smooth as possible.
Yeah. And would you say the drive to I think you mentioned this earlier, but I just want to come back to it. The drive to bring this stuff in house was basically just control and timeliness and things of that sort. Is that the main thing? Were you
Yeah.
not able to find labs in the area that you were comfortable with?
No, it's primarily just the turnaround time, so being being in aerospace, it's when we go to work on what we call an MPI, so essentially a product launch, we lose a competitiveness to a point, because if we do EDM, so we do a lot of electrical discharge machining in-house, we have to send all those out for a lab cut up, and the lab that we use, could take 2 weeks, 3, 4, 5 weeks sometimes, and you're just kinda stuck twiddling your thumbs, hoping it comes out good to get a, "Nope,
Yeah.
this failed, now we have to go back and change it."
Yeah. Now you've wasted 3, 4, 5 weeks depending. And yeah, yeah,
And
I can
it's the
see that.
same reason we're bringing in heat treat and then essentially braise, so a quicker turnaround time, easier diagnose, we could run a sample, it fails, go back, run it again.
Right. 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 All right. Good. Last question for you then. It has nothing to do uh, with what we've been talking about, but uh, I am kind of curious. You're one of the younger people in the industry, I would say. At least we know for sure that you're under 40 years of age, and that's all we
Yeah.
need to know. Uh, I'm curious if you have anything you would say to much younger people who are still high school, college age, that are thinking about getting into either metallurgy or metals industry, generally speaking, thermal processing in any fashion. Any advice?
Oh, that's a little difficult, but I would say, if it's something that you're passionate about, I would say go for it. The schooling might be scary. I will say that the schooling could be scary, but it's a very rewarding and very, how would I say, I felt good about school all the time. Like, it was something that you could put your hands on what's going on and you could see what you did. And when you get into the industry itself, I mean, become best friends with your operators. I'm a pure proponent of, you can learn anything from A to Y in your textbook, but that last letter Z, you're going to get from your operators who've been running the processes, because they're going to know a lot more of what they can do, what's happening in their equipment, what's happening in their furnaces. that your book's not gonna tell you, and it's gonna be that in practice that's going to help put the final polish on your
Yeah,
process and getting
yeah.
conforming parts.
Speaking of polishing, right? The so the so maybe even one more additional. I said that was the last question, but you sparked a thought of me. At one point in your life, you either didn't know of or had no interest in metallurgy and things of that sort. What drew you in?
So, I started off my schooling as a mechanical engineering major, and I was in my 3rd year of schooling, and I was bored. I didn't
Okay.
it sounds weird, I didn't have joy doing my homework, which I don't think most people do, but I didn't really see myself being a mechanical engineer anymore. I didn't see myself being able to have a career in it, doing my anything related to my homework in that end. As a mechanical at the school I went at South Dakota School of Mines, we have to take a metallurgy class. And I took that class and I was like, this seems real interesting. You have your basically forensic side going to failure analysis and all that as well. And I'm like, this is interesting. And then, I talked to the head of department. I switched, hoping I would be happy. And honestly, I was overjoyed. It was the best decision I've ever made.
Just because you enjoyed what about it? I mean, just being able to see why certain metals do certain things, or what was
It
it
was
that?
an array. It was, that was there. Then there was, the aspect of I learned really well based on theory and how to derive from where you came from. And metallurgy is a lot of deriving to find your problem. There's no one key solution in metallurgy to fix a problem. Factors. And
Yeah.
I love learning that way. I love that kind of process.
Yeah, putting all the parts together,
Yeah.
figuring it all out. Yeah, yeah, it's pretty interesting. I often find when we do a series of radios called Next Gen, which you would fit in nicely, we'd talk more about your personal experience and whatnot. But I'm always fascinated that when we ask people, did you ever think there was so much to metallurgy? You know, that it's fascinating when you get right into it, right? There's a lot to be learned and there's a lot of mystery out there still, how things work.
Yeah, I will say, when I went into it, they had 3 different branches. You had your physical metallurgy, you had your extractive metallurgy, and then your pyrometallurgy, essentially, your
Okay.
heat treat processing.
Yeah.
And I will say extractive, I did very well in those classes. I dislike it a lot, yeah. So
Yeah.
this is, taking gold out of ore
Yeah.
and everything. I disliked it,
You
but
you did like it or you disliked it?
I disliked it.
You
I
just
got great grades in it, but I did not
didn't like it.
ev yeah. It was more of the physical and the processing side of metallurgy that
Yeah.
is what I was keen on, yeah.
Yeah. Very good. Very good. Caitlin, thank you very much. Thanks for spending some time with us. I know you probably have to get back to Moeller and start actually doing some real work, getting ready for your NADCAP. So, listeners, viewers, thank you very much. Appreciate you taking some time to listen to our interview today with Caitlin Kirsch, and what a great time. I really do appreciate it, Caitlin. It's good to hear about your experience. If you want to get a hold of Caitlin, you can just email me and I'll make sure that you get in touch with her. My email address should be on the screen, doug@heattreattoday.com. If you'd like to get in touch with Caitlin, just drop me a line. If you like what you hear on these episodes, please give Heat Treat Radio a 5-star review or a like on Spotify, Apple Podcasts, Google Podcasts, wherever you happen to listen or watch your podcast. Please give us a positive review. If you would like for us to have an episode on something specific on Heat Treat Radio, we are very open to that. So please send us an email. Send me an email, doug@heattreattoday.com, and we can do our best to try to get that in there. And as always, this and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. If you do want to do that again, just email me, doug@heattreattoday.com. And I'm your host, Doug Glenn. Thank you very much for listening.